We are Group 13 working on the topic of buckling in respect to radius of gyration and profile. Today, we would like to quickly introduce our investigation. First, let us explain the principle behind. Buckling is the deformation that occurs when a structural component is under load. In the case of a column, when a vertical force is applied, it buckles in the shape of bowling. Radius of gyration is a concept used to compare how different profiles will buckle differently. It is expressed with this formula, where R is the radius of gyration, I is the moment of inertia, and A is the sectional area of the profile. The moment of inertia changes with each shape of profile, thus establishing a relationship between radius of gyration and profiles.
With this interactive setup, we are able to clearly compare the degree of buckling of different profiles. The first goal of this investigation is to understand the relationship between the degree of buckling and the radius of gyration. As you can see, the degree of buckling decreases from left to right, in the order of H-beam, square beam, rectangular beam, I-beam, C-beam, and T-beam. Since the columns are all hand-cut and hand-glued, the slight inaccuracies might have contributed to the physical experiment and digital stimulation having some differences. Despite that, we are still able to discover that the higher the radius of gyration, the lower the degree of buckling, establishing an inversely proportional relationship between them. The second half of the investigation is to develop a profile design that will best resist buckling. In the physical experiment, the hollow square beam shows the smallest degree of buckling. This column is designed as the hollow square beam's bending moment, and we can see that the profile demonstrates great resistance and buckle little even under load. Thank you.